Harrison from CSIRO in Perth, Western Australia. Thank you for the invite. Shame I couldn't be there. Today I'm going to talk about the essential characteristics for legumes suitable for conservation agriculture. Conservation agriculture or regen agriculture in Western Australia, it's been going on for a number of years here as catching up to the rest of the world. They're both very similar things. They're just called regenerative agriculture in Australia. WA has been minimum till for 30 plus years, and the WA soils are very similar too. So these sandy soils of southwest WA are very similar to Vredenburg, Sandveld and Darling. The organic carbon is below 1.5%. And very low in nutrients. We're seeing in our research that consumers are driving demand and research for more sustainable products. But I'll be talking about how to include the legumes into the mixed farming systems and what you should be looking at in that sort of respect, especially behind these principles of permanent soil cover, diversified cropping rotations. So biodiversity, looking towards these polycultures and the benefits of that, and then the minimal soil disturbance. Traditional legumes and their limitations. So the reason why we've gone down the path of breeding new aerial seeded pasture legumes is because of the limitations of the traditional legumes, which are subclover and medics. So medics are more on the alkaline soils and subclovers on the acidic, more acidic soils. Some of the limitations that I've put up here have been pulled out of the changing roles for legumes, that citation I've put below from John Howison and the team back in the day. But more importantly, the susceptibility to insects and disease have really become prevalent in the last few years. Shallow root systems, they're not high seed producing plants. They've got a very determined growth pattern, costly on-farm seed production, probably due to the erosion from harvesting and the suction harvesters. High nutrient demand, they're not as phosphate efficient as the new stuff. They've got undesirable hard seed breakdown patterns, which leads to susceptibility to false breaks and those sort of things. They're symbiotically constrained. The rhizobia can be a limiting factor in these systems, and they cannot go down to the low pH that the new rhizobia can. And the new cultivars are nowhere near as successful as the old. But all legumes aren't the same, and I think that's probably the main point all the way through is they're different in nitrogen fixation and nitrogen content, animal feed quality, and there's a huge difference between pulse and pasture legumes. So pulse puts all its nitrogen and the like into the seed, and when that's harvested, you're removing a lot of that, which is against sort of that conservation agriculture principle, whereas pasture legumes leaves the seed in the system. Then you've got the regeneration plus the nitrogen stays, apart from the stuff that's carted away by animals. This is just sort of a visual representation of the insect tolerance example on the left. As you can see, the subclover's been smashed by the red-legged earth mite, creating sort of those windows and sucking the chlorophyll out of the leaves, and they're not touching the ceradella, which is right next to it. And on the right, we've got that false break susceptibility that I was talking about on the previous slide. These are the cotyledons of subclover that are coming up in February on a thunderstorm this year. And as you can see, the bicerula pods, which is a new pasture legume that was bred in the last 20 years, that's still there, and there's no bicerula cotyledons coming through yet. So the hard seed breakdown is later on in the season, and also it's a numbers game with bicerula. These drivers for selection are important to touch on because of the changing rainfall and temperature patterns, especially in Western Australia. Everything's sort of receding to the coast, which in the eastern wheat belt over here in Western Australia, we're getting these false break events where there's more tropical thunderstorms that are coming through and causing these false breaks, which is a rainfall event before the break of the season. Also, the growing season's ending quite abruptly, so things that don't have deep root systems can't hang on as much, and also they've got determinate growth that once they've reproduced, that's it, and you're not going to get more feed and more nitrogen fixation then. The soil profile's been acidifying over time. Insects have just evolved to attack subclover and medics because they've been in the system for so long, and we've got more introduced pests as time's gone on. The photo on the right there is the red clover syndrome that we've been noticing over the last few years that's come in. So that disease pressure's increased, and that's a few scientists have identified as a virus. Seed harvest with a conventional header, more farmers want to harvest it with a direct header instead of the clover harvester, which is detrimental to your topsoil and leaves you open to windblow events. Low palatability and digestibility of traditional pasture legumes really aren't holding up against what we've got in the new suite of legumes. So that has sort of pushed us into these selection traits of going into the new pasture legumes, which is the hard seed breakdown patterns, so the capacity for it to regenerate between and within season, and they're also false break protected. I'll show you a representation in a graph later on. Deep rooting habits, so they're able to push through these subsoil constraints and hold on later in the season when the season ends abruptly. The tolerance to insects and disease, so selecting for that. Seed size, so that's quite an interesting thing with especially how seeds pass through a ruminant. Around that 2 milligram zone is sort of the cutoff line for your seed size and how they can pass through a ruminant. Like a subclover seed's around 8 to 10 milligrams, and it's just getting either crunched up in the molars in the mouth of the sheep, or it's getting digested through the ruminant. Whereas something like Bicerula and bladder clover, up to 60% are going through. High seed yield's very important to touch on as well, because it is a numbers game and you want to sort of get that uniform and succinct germination. The tolerance to pH extremes, and that stands for the rhizobia as well. They're aerial seeded, suitable for that on-farm seed production. So harvestability is so important, so farmers can produce their own seed, store their own seed, seed it the next season or the season after that, and it cuts costs significantly, and that's a huge barrier of adoption. Indeterminate growth habits, so if something's eaten or the season decides to kick on, they can flower again, produce more seed or biomass. Digestibility, that's sort of what we're coming into now, is looking at quality over quantity, and that's throughout the season. So that's got to be through the vegetative, reproductive, and senesced plant samples. And then that low-cost establishment. So you inoculate once, seed once, and then manage your seed bank. So this is what's happened. We've gone from the medics and the subclover, and we've gone to the progressive annual pasture legumes on the right here. So bladder clover, Bicerula, and Ceredella's in the picture there. And look, we could probably get some further arrows on the right for starting to select for conservation agriculture. So there's a few examples of them there of the second generation of pasture legumes that have been bred by people here in Western Australia, especially the one that we bioprospected or biopirated from South Africa, which is French Ceradella. That's been quite successful over here when it was re-engineered to have hard seed, as everything that was found in cultivation had soft seed. Work by Dr. Brad Nutt, Bicerula, bladder clover, gland clover, yellow Ceradella and rose clover. So with this information, you should be looking at, if you're especially a farmer or an advisor, is you've got to realise that it's all horses for courses. So there's not a pasture legume that will just go across all soil types and deal with all the constraints. So important to note there that there's only a few cultivars and genuses or species that can go down into those acid zones, and that's really important to touch on because they can all grow in the sweet zone, and if you just want a lime and get them up to that sweet zone of between 4.8 and 7.9, if lime's affordable, fair enough, you've got to go for it. But also on the medic country, and that's above 7.9 in pH and calcium carbonate, is what we're trying to understand is what options can go into that sort of territory. And from this dryland pasture legume systems project that Dr. Angelo Loy was talking about, Trigonella and bladder clover are sort of getting pushed into those levels there. And these have all been sort of focused on in the low to medium rainfall zone, and they're all header harvestable, as you can see, with the medics and subclover that can't. There's only really one plant that can sort of handle all the insect pressures, and that's gland clover, but that's more of a filler in the system. But we're sort of further looking at the nutritive value at senescence. So to fill the feed gap, we want quality senesced dry matter, and that's sort of, as you can see there, the red stuff in the yellow Ceradella gland clover and the medics is very low, whereas it's quite high in bladder clover and balancer clover. So we'll be looking at further at that when we're in our breeding programs. Talked about this earlier with rhizobia limitations. You have to get it right the first time. And inoculant and seed spacing is so important that, especially with the granular products, you've got to place them exactly next to the seed, otherwise they will not nodulate and fix nitrogen to the degree that you're after. The pH tolerances of rhizobia on the graph show the table there next to us is next to the writing, shows that Ceradella rhizobia can really go across the plethora of pH ranges. Herbicides, they're getting phased out in the conservation agricultural system, which will be, the rhizobia will be cheering that on. Also the desiccation tolerances, so lucerne and annual medics, their rhizobia can, sit in a glass of water on your desk for months at a time and survive. They are compared to something like subclover's rhizobium, which, after 48 hours, it starts going backwards really quickly in terms of cells per gram. Also the promiscuity and specificity of certain plants as well. So rhizobia can be very specific, or it can be quite promiscuous. So to maximise this rhizobial inoculation, you've got to really choose your level of your technique of delivery. As you can see there, the peat slurry is the low cost. You've got to apply it to the seed. Ease of application is very easy and it's high effectiveness, and that's in a wet soil. The only thing that can be used in dry soil is clay granules, but that's quite a high cost. Medium ease of application and medium effectiveness, it just depends on the operation and the operator and the conditions. So you can't leave that huge gap between the seed and the inoculant. And certain rhizobia strains are better than the others for pre-inoculated seeds. So the only pre-inoculated seed where rhizobia would be alive is in the Cynorhizobium range, which is your Medics and Lucerne. So high input, high output establishment, which is very important to touch on. So there's the establishment cycle in year one. So you seed and inoculate a new pasture, encourage that maximum seed set, harvest the nursery paddock so that hasn't been grazed, or it has been grazed but hardly any weeds in it. So then you can harvest that, store it in the silo, and then start the establishment cycle again on your farm. Year two, always seed a cash crop, so a canola or a wheat or a barley in the second year to utilise that N. Otherwise, you're just going to be feeding your weeds with that nitrogen. Then there's Dr. Angelo Loy in a beautiful Cerridella pasture. Always let legumes regenerate in the third year. This will then set up your seed bank beautiful for the future, and it's a foolproof method after you've been through 3 years of just concentrating on treating your pastures like a crop. So that regeneration all comes down to the hard seed breakdown. So patterns of hard seed breakdown are reliant on temperature, humidity, and their fluctuations. Animal ingestion can induce hard seed breakdown. We talked about the 2 milligram size. Disaster resilience. So a protected hard seed bank will help you out in all seasons. No two seasons are the same. You guys know that better than anyone, that you cannot predict the weather, but if you've got a resilient hard seed bank, you've got your pastures on demand. All legumes have different patterns which suit the different seasons, and I'll show you a graph with that later on. And early and late emergence could work to drought-proof your farming system. So here's a few factors affecting hard seed breakdown. This is taken out of a recent publication looking at the hard seed dormancy in Lebechia from South Africa. So another thing was stolen from you guys, thanks very much. And the hard seed incidence and breakdowns, really you just look at G times E, so genetics and environment, but the environment of the seed is being studied quite heavily in this recent paper, along with the maternal genetics. But yeah, it's if you're looking at further reading, go for that. So here's the graph I was talking about earlier. That's the visual representation. So the hard seeds on the y-axis, which is where decreasing hard seed levels equals sort of the germination or germinable seed, and you've got the months along the bottom. I haven't had to change this because you're in the southern hemisphere as well, so it saved me a bit of time, but along the bottom are your months of that. So the shaded zone that's just come up there now represents in WA the sort of the average break of the season in that zone. The red line is Bicerula up the top there, and it's way too hard. Only 5% hard seed breakdown, or 95% sort of hard seededness still in that time. But it's a numbers game for them because they can produce a huge amount of seeds per plant, and also they're better in sort of a long-term hard seed bank when they regenerate every year. The green line with black dots is Trifolium spumosum, which is bladder clover, and there's two of them in that to represent that there's huge differences in hard seed breakdown patterns both within species and between species. So that top one, the top spumosum, is way too hard. Only 10% breakdown, still 90% hard seeded. whereas the next one along has that ideal hard seed breakdown where you're going to get that uniform and succinct germination for things like summer sowing and twin sowing, as well as the regeneration each year, which can pop up and provide sort of good cover really early and really quickly without competing with the weeds. And that 50% germinability at the break of the season is sort of what we're breeding for. Then the blue line, which is subclover, Trifolium subterranean, it breaks down too early, and that's what we're talking about with the susceptibility to false breaks, resulting in a huge amount of seedling death. So going to the conservation agriculture principles. So the first one we'll talk about is the permanent soil covers of the mulching. As you can see on the left there, that we've got a beautiful matting of Ceradilla with fallow plots in between it. It's created a great sort of layer to stop germination from things like Afghan melon and fleabane, which will help with your weed control in the summer months. Also trapping in a lot of moisture and making it cooler conditions, which really looks after your soil metagenomics as well. However, the incorporation the year after, I wish I had a disc machine. As you can see there, you can imagine how much mulch I had to pull out away from underneath the tines, the knife points that I had, which was extremely frustrating on the day, but worth it, and dragged it all across the plot, so I had to spread that over again. So if you've got a disc in your system, it helps a lot. As you can see in the middle there's a bit of green tinge coming through from the fallow plots because of the sort of that moisture and the space for the weeds to germinate, where there's nothing in the mulch plots. I think it's important that, especially for breeding and going forward, to selecting what you need to put into your paddocks for the best mulching is selecting both prostrate and erect growth habits of these forage legumes. We haven't done any research in the hard seed breakdown patterns under the mulch, so that's important. That'll be important to understand going forward with the new technology of conservation agriculture. This nitrogen mulch that Angelo's talked about in his talk today is really beneficial for cereal and oilseed crops, especially in the quality of them, so the proteins and oils. And there's no difference between in yield between legumes with and without that inorganic nitrogen. The fertility in the soil cover, this is a great principle because you've got to put back in what you're taking away. And a recent publication by Smith et al., which also has been research done over your side of the world, that legume cover crops increased wheat grade protein as well. So it's happening all over the world. So it's a great thing to include these legume cover crops. The next one's biodiversity. So you increase your biodiversity in your in sort of your pasture. But it's all about quality versus quantity now, especially for animal production. So this is some recent stuff from Dr. Dean Thomas at CSIRO and his colleagues, along with Dr. Harley Norman, where 5% unit increase in pasture quality or digestibility is equivalent to 1 tonne a hectare increase of biomass production in terms of gross margin outcome. And that's such a huge revelation, because we've been chasing quantity for years and sort of dismissing quality, which could have put us back for a long time. These mixtures could be a good idea both within crop rotations and between crop rotations. So when these people have been collecting pasture legumes over in, say, the Mediterranean basin, everything's in a mixture over there, and it's such a such a sustainable system because you've got different pasture legumes that can become more prevalent in different years. And this, just a slight touch on bees and the legume pollen production, that legumes have been shown to produce a lot more pollen than certain other plants, which could, feed these bee populations as well that have been questions around the world. The final principle is the minimal soil disturbance. As I said before, here in WA, we've been minimum tillage for 30 years. Legumes have been bred for these systems, especially the shallow sowing depth, and there's where seed size comes into it again. Twin sowing could potentially, you can seed once in 2 years, and that's a great technology where you put the hard seeded pasture legume in with your wheat crop. You get your wheat or barley crop that grows that year, you harvest that, then without seeding the next year, you've already put the hard seeds in the ground, so they're going to regenerate the year after. Harvesting these traditional legumes obviously is going to be, not fitting. It won't fit in with this minimal soil disturbance of the conservation agriculture principle. And as you can see, all the top soil's just been pushed into the air by harvesting subclover in the picture there, and that's led to huge amounts of erosion in Western Australia alone and Southern Australia. The next generation of pasture legumes that we've been looking at from that dryland pasture systems project that has been mentioned a couple of times during this talk, and I can't go any further without saying thank you to those funding bodies in the bottom left-hand corner, especially the Trigonella scorpiurus, Lotus, and bladder clover. Also, it'd be remiss of me not to mention John Howson's Legume ambigua, that the cultivar called a Santi that was given to us from after collections in South Africa, and that's sort of going out into the marginal lands, and instead of having an annual lay system, this could be working towards a perennial lay system. So as I said earlier, that breeding these new species, we're actually looking at the animal benefits at the same time. So they do have anti-helminthic properties, but we've kicked the goals with the Ceradella on those those coarse textured acid soils. So these are suited for alkaline, fine textured soils, with Trigonella on your top on the left, Scorpiurus, which doesn't look like a legume at all, but it's a really cool plant because it's really high feed value and actually increases the milk content in sheep and cattle in places like Sardinia. So that could be quite exciting if we can figure out how to harvest it without putting a clover harvester over it. Lotus ornithopioides, hard to say. Lotus is down there as well, with really high in those anti-helminthic properties, and then bladder clover, as you can see the seed heads there. I rubbed a few of those out, and they've had between 250 and 300 seeds per head, which is phenomenal. Further looking to the future, I think that a bit more work could be done into Legume ambigua to get different cultivars on different areas of Western Australia, helmet clover, different lotuses, and an interesting publication from Chimfango, Samson Chimfango, this year with forage legumes from Mediterranean fynbos of South Africa with potential for domestication. He's sort of hit the nail on the head with some potential shrub species that could be domesticated and put into the farming system here in WA, and would love to sort of work together with South African farmers to to understand the value of these sort of plants and their grazing systems. But he also saw that there was slope aspect effect in the tissue fibre and mineral composition from, they're facing north or facing south, which is very interesting if you wanted to read up on that one. So finally, to touch on a bit of a concluding remark is the essential characteristics of new legumes for conservation agriculture is just the higher end production is putting more back into the system than you're taking away, and that's important, and it's more likely to happen with the new pasture legumes than the old. Ideal hard seed breakdowns, I think a bit more work needs to go into that, especially under the mulching effect. The deep rooting habit is probably the key because there's minimum tillage and that sort of stuff now to bring the P&K from depth. The deep rooting habit of either shrubs or deep-rooted annual pasture legumes is key to driving this conservation agriculture system. The thing that's a big point to take home today is looking at the nutritive feed value of these pasture legumes and choosing ones that are not necessarily going to produce a huge amount of biomass, but they're going to be really valuable for your animal system. This will increase biodiversity because you'll have a heap of different legumes in your mixtures, along with your grasses and all the different, some weed species as well. To have that biodiversity in the system, you can't go wrong. And then the minimal disturbance, both when seeding and harvesting, these legumes are suited for that. So danke, I hope I said that properly. And any questions, please send it to that email address on there. Thank you very much for having me.